the volume of a pontoon. A pontoon is to be made in the shape shown in this figure that they've given us. The pontoon is designed by rotating this graph, 1 minus x squared over 16, from -4 to +4, about the x-axis, all right? So the x-axis is y equals 0, all right? The disk method is set up so that if you're revolving around y equals 0, your function needs to be in the y equals 0, right? This is already set up this way. So I would use the disk function here. It's not even washer. I don't even have a hole in this thing when I do it because it butts up next to the graph. So in this case, it's already y equals, my x-axis is y equals 0. That lends itself to the disk method, pi r squared, all right? And so for the disk method, I'm going to do pi from -4 to +4, r squared. Now, not that this is a pretty r squared to do, but it's still easier than manipulating this particular function. And so you do have to FOIL here. So you do have to say 1, and then you're going to get 2 of those. So it's going to be x squared over 8 plus, they would give me what, 256? Is that 16 squared? Dx. So that's your FOILing of it. I haven't actually taken the antiderivative yet. And then taking the antiderivative, we're going to leave the pi out here. Antiderivative of 1 is just x. 1/8 x cubed times 1/3. So we get this. And then 1/5 was 1,257. Okay, 1280. There we go. We'll let the book do that one for me. -4 to 4. All right, plug in your 4s. We have 4 minus, that's 64, 24. Oh, I don't have to worry about that, do I? If that's 256 already, right? 16, that was times 5? Oh, well, that's going to be, this is going to be 256 times 4, and this is 256 times 5. So I'm just going to make that 4/5. I've done this too. This is, this you can reduce as well right here, right? By 8. So this is going to be 3 and 8. So that's a much easier fraction to deal with. So my common denominator is 15. So we'll do that. 40 and 20. Oh my goodness. Losing my own mind here. Okay. So that's going to be 40 over 15. The -4 is going to be exactly the opposites here. So we're going to have a -4, a positive 8/3, and a -4/5, but we are subtracting. Right, so that's going to be the same thing, but 60 minus 40. So it's going to be, so for this one, find the volume of the solid formed by revolving the region bounded by the graphs y equals x squared plus x plus 1, y equals 1, and x equals 1. Those are the boundaries. About the line x equals 2. X equals 2 is a vertical line. That means y-axis. X equals 2 for the disk method will require everything be in terms of x. So I would have to take this function right here and rewrite it in terms of x. Good luck. I don't even know that that's possible to get just one x by itself for that function. And so you definitely would go straight to shell here. Like, it's a shifted one. You do have to shift this guy, but at the same time, I don't want to rewrite him. And so it's in terms of x equals 2 for my rotation, but my function is y equals something. That leads you to shell method. When what you're rotating around is a different variable, independent variable, right, then the other one, you want to use shell method, all right? And so we're just going to do our 2 pi r method here. So we're going to say 2 pi, all right? They are telling me that it is when y equals 1. So if I were to plug in a 1 here and subtract that 1 over, you can see that x equals 0 when y equals 1. X equals 0 when y equals 1. And they've already given me x equals 1. So they've given me my top boundary here. My r is going to be a shifted graph here because I am rotating around, as you can see, the line x equals 2. X equals 2. Well, my x's only go from 0 to 1, so that automatically tells me that my line that I'm shifting around is further away. So I'm going to say 2 minus my x is my r. So the distance away from this line is going to be 2 minus whatever my x is. That's how far away from that line I'm going to be. All right, and so that's my r here. All right, and now I technically have two functions that I have to consider. I have the function y equals 1, and I have the function y equals x cubed plus x plus 1. All right, and so I have to consider between 0 and 1 which function is bigger. Well, y is always going to be 1 for the second function here. If I plug in any number between 0 and 1, any positive number, and add 1 to it, it's going to be bigger than 1. So my functions are going to look like this: x squared plus x plus 1 minus 1, because I have this function to consider as well. Two functions. I have the first function and the second function. That is my height of what I'm revolving. That was a minor detail that might come back to haunt us. There we go. All right. So those are my functions. Obviously my ones cancel, right, when I simplify this. And then I do have to FOIL here. I do have to FOIL. So I'm going to say 2 times my x cubed, 2 times my x, negative x times x cubed, and negative x times x. Dx. So I'm going to take my antiderivative here. From 0 to 1, plug in a 1. Common denominator should be 30. So I have 45 minus 16. Yeah, that's right. No. 30. That's right. All right. So 2 pi. $29.